Okay, so today we're going to do 9.1 polar coordinates. And in this is basically kind of just an intro into polar. We're not going to become experts by any means, but we're definitely going to become aware or learn how to understand the polar or how to graph in with polar coordinates. So basically, you have this graph, and this is just like before, but this is now your polar axis. And this right here is your pole. Okay, so everything in polar coordinates is based on distance from the pole to your value, and then the angle counterclockwise from the polar axis. Okay, so when we say the distance to our point or to our location, we're going to say that that's r, the radius, and then the angle that we use to get there, we're going to call that theta. So you see here, I talk about r is the directed distance from the pole to the point. So here I have my point P right here. Okay, so there's my point P. You know what? I'll do it in red. There's my point P. And I had to travel this distance right here in blue. And so that distance to get to there, I called r. Now the angle that created it, I'm going to call theta, right? And so it's just like doing everything that we've done before, but now we're actually calling this my coordinates. So oftentimes polar coordinates are sometimes thought of as vectors similarly because they have a direction as well. So a lot of times we think of polar coordinates as vectors because it feels like it. Then we have, we can see that from this relationship, if I were to draw like a right triangle right here, I now have all of my sine, cosine, and tangent stuff. So one thing we're going to notice is there's a relationship between x and y coordinates and r and theta coordinates, okay? So we're going to use right triangle, or using right triangles, we can see that the following relationships would emerge between x and y and r and theta. So here we say that polar to Cartesian conversion, so we can take polar coordinates and convert them to Cartesian, also known as rectangular, right? Or from rectangular to polar. So we can say that x equals r cosine theta. And if you're not sure where this came from, think of x over r is equal to cosine of theta, and think of y over r is equal to sine theta. That's where it came from. So if we just multiply r over to the other side, we now have x and y. Now going the other way from Cartesian to polar, or from rectangular to polar, we're going to use the Pythagorean theorem, right? Because that's how you can find the third side of or the hypotenuse of a triangle is using x squared plus y squared equals r squared. And then the tangent of theta will always be worth the cosine over the sine, or adjacent over hypotenuse, or adjacent over opposite. Okay, so this is kind of the formulas we're going to use to convert. So I'm going to come down here and I'm going to say write the following in polar coordinates. Okay, so I'm giving you rectangular and I want to end up in polar. So it says I'm given rectangular and I want to end up in polar. So I'm going to use this guy right here. I'm given Cartesian or rectangular and I want to end up in polar. So what I'm going to do is I'm going to say x squared, so 2 squared, plus negative 2 square roots of 3 squared equals r squared. Okay, so this will be 4 plus 4 times 3 equals r squared. So this will become 16 equals r squared. So then we know that r is equal to 4. So we have our radius of 4, okay? Now we can come over here and we can say y over x is equal to tan theta. But we know in this case, y is worth negative 2 square root of 3 over x, which is 2. And that has to be tan of theta, okay? So then we know that theta is equal to tan inverse of negative root 3. So basically what we have to think of, and these twos would cancel, right, is we have to think of tan of what angle would give us negative root 3. Well, we know that that's actually 60 degrees, but if we did 60 degrees, we would get positive root 3. And remember, arctangent only exists in quadrant 1 and quadrant 4, so, or from negative pi halves to pi halves. So what angle would match that? That would be negative pi thirds. So we're going to say negative pi thirds is our theta. So we now have our coordinate 4 comma negative pi over 3, okay? But you could also, if you wanted, you could rewrite this as 4 comma 5 pi over 3, right? So all I'm doing is I'm drawing the unit circle, and I'm saying, well, if this is negative pi thirds right here, what would be an equivalent angle to that? Well, I could also go and have 5 pi over 3 as well. Either one of those would get me to the same location, okay? With a radius of 4 and an angle of negative pi thirds or 5 pi thirds. So what you might notice is there's an infinite number of ways that I could write these coordinates. So that's kind of the problem with polar, and that's also the good thing with polar, but that's also kind of the downside, is there are infinite many ways to write the polar coordinates. However, if we want to write negative 2 square root 3, that's it. That's the way to write it. 2 negative 2 square root 3. There's not some alternate version of it, okay? So why don't you guys take a minute and you try this one over here. You do the same thing for this one. So pause the video and try letter B. All right, so hopefully you guys are going to do the same thing. You're going to say 2 squared plus 2 squared equals r squared. So then we end up getting 8 equals r squared. So then 2 square roots of 2 is equal to r, right? So we get 2 square roots of 2. However, when we go to do, let's see here, we want to do our formula, y over x. So this would be 2 over 2 equals tan theta. So then we have 1 equals tan theta. So then we know that theta is equal to pi over 4. Okay, so then we have 2 square roots of 2 comma pi over 4. Now we could find another one that would do the same thing. We could also say, well, the equivalent angle would also be, if we wanted, 2 square roots of 2 comma negative 7 pi over 4. That would also work, right? We could do that, or we could do what, 9 pi over 4 as well. Yeah, we could do 9 pi over 4 also. We could do 2 square roots of 2 comma 9 pi over 4. And all of these are the same location. They would all end in the same location. However, for the Cartesian or the rectangular, it would just be 2 comma 2, okay? So something just to kind of note is there's an infinite number of ways to do these angles, right? So now we want to go the other way. Now we want to write the following as Cartesian coordinates. So I'm going to go, we already are given polar, so 4 comma, so this is my r, and this is my theta, right? So I'm going to go up here, and it says if I want to find the x and the y, I just do r cosine theta and r sine theta, because remember that sine and cosine are associated with y's and x's. So all I'm going to do, is I'm going to take, and I'm going to say that x equals r times cosine of theta. So r is 4, and we're doing the cosine of pi over 4, but that's an easy one, right? That's just square root 2 over 2. So this just would become 2 square roots of 2, okay? Now we do y, similarly, y equals our sine theta, because y is associated with sine. So then we have y equals 4 times the sine of pi over 4. So then y equals 4 times square root 2 over 2, which is equal to 2 square roots of 2. Same as before, right? So then our coordinates are 2 square roots of 2, comma, 2 square roots of 2. Okay, now what I should have probably done, to be honest with you, is I should have graphed this first and kind of taken a look at where I end up. 4 comma pi fourths, that would be here, right? So this is 4, and this angle is pi over 4, okay? So I'm in quadrant 1, so that makes me realize that these are both positive values. So sometimes you got to make sure that you attach a negative or a positive to them. So remember what quadrant this puts you in. Since this puts me in quadrant 1, I'm okay, and I get to use both as positive. So now over here, I'm going to do the same thing. So pause the video and give this one a shot, you guys. Okay, so now you guys hopefully just said that x is equal to 3 times the cosine of pi over 3. So x equals 3 times, now cosine of pi over 3 is 1/2. So this will become 3/2. And we know that y is equal to r times sine of pi over 3. So we know y is worth 3 times square root of 3 over 2. So y equals 3 square roots of 3 all over 2. Okay, let me double check and make sure we're doing okay. 3 squared to 3 over 2 and 3/2. So yep, we have this. So we do 3/2, comma, 3 square roots of 3 over 2. Now let's just double check and make sure that they're both positive. So let's graph this polar. So we would go angle of pi thirds, and we would go a distance of 3. So this has a distance of 3, and this has an angle of pi over 3. Okay, so yeah, we're still in quadrant 1, so this is perfect. Okay, so that's how you can convert to Cartesian from polar. Okay, now something I want to kind of talk to you guys about is in polar coordinates, the radius can be negative and be a negative value. So we can convert to a positive radius just by adding a pi. Basically, it feels like you reflect across the origin by adding a pi to the angle. So if we wanted to plot -1 comma pi halves, we would just plot 1. We would plot, let me do it in red. We would instead plot 1 comma. Now, if we add pi halves, I'm sorry, pi to pi halves, wouldn't we get 3 pi halves? So let's see. We go 3 pi halves. So here's pi halves, 2 pi halves, 3 pi halves, and then we go a distance of 1. Okay, so this would be that angle, right? So this would be 3 pi halves, and this would be a distance of 1. So that would be the exact same location as this. So what a negative radius does is, if you want to think of it another way, what I could have done instead is I could have plotted 1 pi halves. So what I could do is I could just plot 1, right? So here's 1 pi halves. And then I realized that the negative radius would make it reflect. So then I would end up plotting it down here instead. Okay, so that's another way you can think about it. All right, so let's do this next one. So this is -3 pi 6. So I'm really going to call this +3, but then I'm going to add pi to pi 6. So normally pi 6 would be right here, right? And that would be 3 comma pi 6. But this is not a +3 radius, so we have to reflect it, and it would come over here. And this would be -3 comma pi over 6. And that's one way to do it. Or better yet, so the green would actually be the right answer. This is actually the correct answer. But we could just do by adding pi, we could say, well, pi 6 plus pi is 7 pi over 6. So where would that be? Well, let's look. Let's go in blue. Here's 6 pi 6. Here's 7 pi 6. And then we go 3. We'd end up in the same spot. So this and this are the exact same thing, okay? There is no difference between them, but they both ended up right here, okay? Now you guys try this last one. Try to convert that negative radius and turn it into a positive radius, and then pay the price. All right, so hopefully you did this. 2 comma, now negative pi fourths would normally be in quadrant 4, but then if you add a pi to it, let me see, negative pi fourths plus 4 pi fourths, which would be a pi, would be 3 pi over 4. So 3 pi over 4 is right here, right? Just like that. And then we have a distance of 2 traveled, okay? So this is 2 comma 3 pi over 4. And this is where it would be located at right here. Okay, so those are our 3 ways that we can undo a negative radius. I just add pi to the angle and that fixes it. Okay, so now I'd like to transform equations from polar to Cartesian. Okay, well, what we're going to do is we're going to kind of use all the formulas that we've had so far. Now, I need r squared because remember, we have this formula way up here where this formula told me that r squared is equal to x squared plus y squared. So if I could get r squared, I'd be okay. So what I'm going to do is I'm going to multiply both sides by r. So I'm going to take and I'm going to do r equals 6 cosine theta, and I'm going to multiply an r here. I'm going to multiply times r here. So this will now become this will now become r squared is equal to 36 r cosine theta. No, I'm not squaring. I was, in my mind, I was doing something else. So this is 6r cosine theta, right? However, what is r squared worth? Well, we said up here that if you have r squared is worth x squared plus y squared. So I can come over here now and I can say that x squared plus y squared is equal to 6r cosine of theta. But wait a minute, what's r? Isn't r cosine theta, isn't that worth, if we go way back up here again, isn't r cosine theta worth x? So now I can go way back here and I can say 6 times x. So we have x squared plus y squared is equal to 6 times x. So when you're working with these, you're trying to find ways to use the formulas that I listed above to recreate x's and y's and get rid of all the r's and the cosine thetas. You want everything in terms of x's and y's. So now I have x squared plus 6x plus y squared is equal to 0. Now, if you're asked to write this in perfect form, you could complete the square. So this is the answer I think the book will take. But down the road, they may ask you, what shape is this? So we're going to complete, let me see. No, I think that actually, they may ask us to complete the square. So we're going to do x squared. Now let me write this in red. So we're going to do x squared plus 6x plus, now completing the square of x squared plus 6x would be plus 9. Right? So I just added a plus 9 there, plus y squared. So the left-hand side of this equation has a plus 9. So the right-hand side must also have a plus 9. So this becomes x plus 3 quantity squared plus y squared equals 9. Oops. I think I messed up. Yeah, hold on real quick, you guys. I forgot to do something first. Right here, to move this 6x over, I had to subtract, right? So I had to subtract 6x from both sides. So this would now become x squared minus 6x plus y squared equals 0. That was my mistake. Sorry about that. Now we complete the square and we do x squared minus 6x plus 9 plus y squared equals negative 9. So now we have x minus 3 quantity squared plus y squared equals, plus 9, sorry about that, equals 9, or 3 squared. And the reason you want that is because then you can write this as a circle with a radius of 3, and it shifts over up 1 or over to the right 3 and up 0, and then we go up 1, 2, 3, down 1, 2, 3, here 1, 2, 3, and we now have a circle of radius 3. So that's what this shape is right here. Maybe I should write this over here. X minus 3 squared plus y squared equals 3 squared. So this has a radius of 3 and a center at 3, 0. Okay, so this information we can pull from this equation. So that's why, so what that's telling you is this right here is actually a circle. Okay, but we didn't really see it until we converted it to Cartesian. Or I'm sorry, converted it to Cartesian. Now we can go the other way and we transform an equation from rectangular or from Cartesian to polar. Okay, so we know that x equals r cosine theta, and we know y equals r sine theta. So let's plug that in. So this becomes 4 times r cosine theta times r sine theta, and that equals 9. But if I clean this up, this becomes 4r squared cosine theta sine theta equals 9. And let me see how much further they want us to go. If I want, I think in your book, they want you to do something fancy. So technically that is a conversion the way below. But if you want to get fancy, if you remember from chapter 7, that's actually, if I just take the 2 out, that's actually the double angle, right? Because 2 times 2 is still 4, so I'm still dealing with the same 4 that I had right here. But now I have the double angle. So this is 2r squared times sine 2 theta, excuse me, equals 9. Okay, so we have 2r squared sine 2 theta equals 9. And you know, it really depends on this. So this is technically the answer, but it depends on what's asked of you. They may want to know r. So you could just say, well, r is equal to 9 divided by, r squared, I should say, is equal to 9 divided by 2 sine 2 theta. And then you could say r is equal to the square root of 9 over 2 sine 2 theta. But I think for this class, I think this will be acceptable. I'm pretty sure I saw that when I was making up your homework. So this should be acceptable for that. But you could get fancy with it if you want. And you could do plus or minus as well. But that's going to do it for this video, you guys. We're not going to go too crazy into polar. We just want to have an intro so you guys kind of know what it is and how to graph polar, understand the idea about converting, understanding how a polar equation actually can symbolize something you don't think of. Graphing polar we'll do in the next section in 9.2, graphing polar equations. But that's going to do it for this video, guys. Thanks for watching.